हेलो स्टूडेंट्स, कैसे हैं आप सभी लोग। अ, आज हम डिस्कस करेंगे क्रिस्टल लैटिस एंड यूनिट सेल्स. In our previous video we have discussed about amorphous solid and crystalline solids and the difference and the characteristics between them. Okay, here we will discuss about the crystal lattice, the unit cell and the type. Okay, so start with crystal lattice. What are crystal lattice? Crystal lattice is a representation of a crystalline solid. We know very well a crystal is made up of well arranged particles. These particles, if we represent these particles with the help of points, these points are called lattice points. The complete framework formed is called crystal lattice. So crystal lattice is a framework of particles which are represented with the help of dots. Okay, with the help of lattice points, with the help of points, these points are called lattice points. Okay, so lattice points are those points which denote a particle within a solid. Okay, a unit cell is a three-dimensional unit of a crystal lattice which when repeated on one another form a whole crystal. Okay, suppose this is a complete crystal lattice. Okay, this is the smallest three-dimensional part of this crystal lattice. This is the smallest three-dimensional part of this crystal lattice. This represent a unit cell. So a unit cell is the smallest three-dimensional part of a crystal. Okay, these three-dimensional part repeat one another over another and form a whole crystal. So you can say it is a kind of building block. Okay, it is a kind of building block of a crystalline solid, and it is formed by some points. These points are called lattice points. A unit cell may be of two types. It may be primitive or simple cubic cell. It may be non-primitive or centered unit cell. Okay, a primitive unit cell has particles only at corners, like this. The particles represent only at corners. Okay, I'm denoting these particles with the green dots. Okay, you can understand the particles are present only at corners. Okay, these green dots are the particles. Okay, non-primitive unit cells are those unit cells which have particle not only on vertices or the corners but also at the center of edge, center of center of face, or you can say center of unit cell. Okay, non-primitive unit cell may be BCC, body centered cubic cell, FCC, face centered cubic cell, and ECC, end centered cubic cell. Okay, body centered cubic cell has particles only at vertices, not only at vertices but also at the center of the unit cell. In the same way, we will see the FCC, okay, and ECC now. Non-primitive unit cell. See, first of all, face-centered unit cell. Okay, face-centered means face. Its name indicate face-centered unit cell. FCC, face-centered unit cell. This is a unit cell. Here, the particles are present at corners. Okay, these are the corners. With corners, the particles are also present at each face of the unit cell. A unit cell has 6 faces. Total number of faces in a unit cell are 6. So 1, 2, 3, 4, 5, 6. So a unit cell, face-centered unit cell, FCC, face-centered unit cell, has total lattice points 8 at the corners plus 6 at the faces. Total lattice points become 14. So it has 14 such sites which has particle. Okay, so there are total lattice points in face-centered cubic cell 14, 8 at the corners and 6 at the faces. Okay, a body-centered unit cell has total 9 lattice points. Okay, this is a unit cell. Here particles are present at corners always, because it is a centered cubic cell. Particles are present at corners as well as at the center of the unit cell. So total lattice points 8 of corner and 1 of center, total number of 9. 9 lattice points. Okay, now see, uh, this is end centered. End centered is a kind of face centered unit cell. Is a kind of face centered only. Here particles are present at corners always, like always. Particles are at corners like this. 1, 2, 3 to 8 particles are present at corners. So 8 lattice points of corners are there. Corners 8 lattice point, and any two opposite faces, any two opposite faces also have particle. Okay, so total number of lattice points 8 of corner and 2 of faces become 10. Okay, now we'll see the contribution of particle, which particle which is present at the edge. Okay, this is a crystal lattice, and the particle which is present here is shared by total 8 unit cells. Okay, these are total 8 unit cells. 1, 2, 3, 4. Okay, these are in the previous in the back unit back layer. In the front layer you will find 1, 2, 3, 4. So 4 at the back, 4 at the front. Total number of 8 unit cells share this particle. So how much share is there in one unit cell? It's 1 upon 8 part is shared in one unit cell. Okay, since 8 unit cell, 8 different unit cells share this single particle, so share of this one particle in one unit cell is 1 upon 8. Okay, now we'll see the face particle which is present in the face. We'll see the face particle. Uh, the face particle is shared by two different unit cells. 1, 2, 2 only. Okay, so one unit cell contains its 1 upon 2 part. Now we'll calculate the number of particles in one unit cell. Simple cubic, body centered cubic, face centered cubic. Okay, we know very well simple cubic cell has particles only at corners, and the corner particle has 1 upon 8 contribution. The total contribution is 1 upon 8. Okay, and total number of corners are 8 in one unit cell. So particle become 1. Okay, there are 8 corners, and the contribution of each corner in the unit cell is 1 upon 8. So total number of particle become 1. In the same way, body centered cubic has two different type of lattice points. One has 1 upon 8 contribution, which is present at corner, and each corner has, and there are total number of corners are 8. Okay, total number of corners are 8, and one particle is present at the center of the unit cell. Okay, this is the corner particle, This is the center particle. Okay, center. And total number of particle become 1 upon 8 into 8 is equal to 1, and plus 1, 2. In the same way, face-centered unit cell has particle at corners, and since there are 8 corners, so we have to multiply it by 8. 1 upon 8 into 8 is equal to 1, plus each face has one particle, and the contribution of phase particle we have already studied is 1 upon 2, because it is shared by two different unit cell, and the number of faces in the unit cell is 6. Okay, so number of particle in FCC is equal to 1 plus 3 is equal to 4. So there are 4 particles in FCC, there are 2 particles in BCC, and there is 1 particle in simple cubic cell. 1 particle means 1 sphere. Okay, these particle may be atom, these particle may be molecule, these particle may be ion, depending upon the type of crystalline solid. If it is an ionic solid, then they are ions. If it is a molecular solid, then it is a molecule. If it is a covalent or metallic solid, then it is atom. Okay, so all the particles we represent with a single term. This is what? Sphere. Okay, we call all the particles with a single term sphere. This sphere may be molecule, this sphere may be ion, and this sphere may be atom, depending upon the type of crystalline solid. So in this video we have discussed only this thing. In our next video we will discuss the packing in a crystalline solid, one dimensional, two dimensional, and three dimensional. Please like this video and subscribe to my channel.